According to the National Electrical Code, or NEC, 2-inch rigid nonmetallic conduit, or RNMC, installed in a residential garage and strapped to a concrete block wall 4 feet off the floor would be considered subject to physical damage. NEC Article 350.30 A2 states that electrical raceways and enclosures in commercial and industrial buildings shall be protected where subject to severe physical damage. NEC Article 334.15 B states that RNMC shall be permitted in areas not subject to severe physical damage by the NEC. Since a residential garage is not a commercial or industrial building, the NEC does not specifically require protection of RNMC in this location. However, the requirement for protection against severe physical damage still applies. In this case, the RNMC is installed 4 feet off the floor and strapped to a concrete block wall. While this provides some protection against physical damage, it is not sufficient to prevent damage from a vehicle or other heavy object that could impact the conduit. Therefore, the RNMC would be considered subject to physical damage and would require additional protection such as metal conduit to meet the NEC requirements. Let's delve further into the NEC requirements and considerations for protecting electrical conduits from physical damage, specifically focusing on rigid nonmetallic conduit, or RNMC, in residential garages. The primary concern stems from the potential for mechanical damage that could compromise the integrity of the conduit and the conductors it houses. While the NEC doesn't explicitly mandate the same level of protection in residential garages as it does in commercial or industrial settings, the general principle of safeguarding electrical systems from physical harm remains paramount. The NEC guidelines serve as a baseline for safe electrical installations, and local jurisdictions may have additional requirements or interpretations that further emphasize the need for conduit protection. Firstly, the location of the conduit significantly influences the likelihood of physical damage. Conduit positioned closer to the floor is more susceptible to impacts from vehicles, equipment, or even accidental bumps. Secondly, the type of material used for the conduit plays a crucial role in its ability to withstand physical stress. RNMC, while durable under normal conditions, may not offer sufficient resistance in areas prone to heavy impact. Thirdly, the method of securing the conduit also affects its vulnerability. Conduit that is loosely supported or inadequately anchored is more likely to be dislodged or damaged upon impact. In residential garages, common sources of physical damage include vehicle collisions, falling objects, and the movement of tools or equipment. These potential hazards necessitate careful consideration of protective measures to ensure the long-term reliability and safety of the electrical system. When assessing the need for additional protection, it's essential to consider the specific characteristics of the garage environment. Garages used for parking vehicles are inherently at higher risk of impact damage compared to those used primarily for storage. The presence of heavy machinery or equipment further increases the likelihood of physical harm. The NEC provides various options for protecting conduits from physical damage, ranging from simple barriers to more robust encasements. One common approach is to install metal conduit, such as rigid metal conduit or intermediate metal conduit, which offers superior resistance to impact compared to RNMC. Another option is to encase the RNMC in concrete or other protective material, providing a physical barrier against potential damage. Additionally, the use of guards or barriers can help deflect impacts from vehicles or other objects. These protective measures should be selected based on the specific hazards present in the garage and the level of protection required. In some cases, simply raising the conduit to a higher elevation may be sufficient to minimize the risk of damage. However, this approach may not be feasible in all situations, particularly where headroom is limited. Regardless of the chosen protection method, it's crucial to ensure that the installation complies with all applicable NEC requirements and local codes. This includes proper grounding and bonding of metal conduits, as well as the use of approved fittings and connectors. Failure to adhere to these requirements can compromise the safety and integrity of the electrical system. In summary, while the NEC doesn't explicitly mandate the same level of conduit protection in residential garages as it does in commercial or industrial settings, the general principle of safeguarding electrical systems from physical harm remains paramount. Factors such as conduit location, material type, and securing method all influence the likelihood of damage. By carefully assessing the potential hazards and implementing appropriate protective measures, it's possible to ensure the long-term reliability and safety of electrical installations in residential garages. Furthermore, it is important to consult with a qualified electrician or electrical inspector to determine the specific requirements for your area and to ensure that the installation meets all applicable codes and standards. They can provide valuable insights and guidance based on their expertise and knowledge of local regulations. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable working with electricity, it's best to leave it to the professionals. They have the training, experience, and equipment necessary to perform the work safely and effectively. In addition to the physical protection of conduits, it's also important to consider the potential for environmental damage. Garages can be exposed to moisture, chemicals, and extreme temperatures which can degrade the conduit and conductors over time. To mitigate these risks, it's important to select conduit and fittings that are suitable for the environment in which they will be installed. For example, if the garage is prone to moisture, it's best to use watertight conduit and fittings. Similarly, if the garage is exposed to chemicals, it's important to use conduit and fittings that are resistant to those chemicals. Regular inspections of the electrical system can also help identify potential problems before they become serious. Look for signs of damage such as cracks, corrosion, or loose connections. If you find any problems, it's important to have them repaired by a qualified electrician as soon as possible. By taking these precautions, you can help ensure the safety and reliability of your electrical system for years to come. Finally, always remember to disconnect the power before working on any electrical equipment. This will help prevent electric shock, which can be fatal. If you're not sure how to disconnect the power, consult with a qualified electrician. Electrical safety is paramount, and it's always best to take precautions to protect yourself and others. Now let's consider some specific scenarios and how the NEC guidelines might apply. Firstly, imagine a residential garage used primarily for parking vehicles. In this case, the risk of impact damage is relatively high, particularly near the floor. The NEC might suggest using rigid metal conduit or encasing the RNMC in concrete to provide adequate protection. Secondly, consider a garage used mainly for storage. Here, the risk of physical damage may be lower, but it's still important to protect the conduit from potential hazards such as falling objects. In this scenario, raising the conduit to a higher elevation or installing guards or barriers may be sufficient. Thirdly, suppose the garage is used as a workshop. In this case, the risk of physical damage is likely to be higher due to the movement of tools and equipment. The NEC would likely recommend using metal conduit or encasing the RNMC in concrete, as well as installing guards or barriers to protect the conduit from impact. In each of these scenarios, the specific protective measures should be tailored to the specific hazards present in the garage. There is no one-size-fits-all solution, and it's important to carefully assess the risks and select the appropriate protection method. Furthermore, it's crucial to consider the aesthetic impact of the protective measures. While safety is paramount, it's also desirable to maintain a clean and organized appearance in the garage. The protective measures should be installed in a way that minimizes the visual impact and blends in with the surrounding environment. In some cases, it may be possible to conceal the conduit and protective measures behind walls or ceilings. This can provide a more aesthetically pleasing appearance while still ensuring adequate protection. However, it's important to ensure that the concealed conduit is still accessible for inspection and maintenance. The NEC also addresses the issue of conduit fill, which refers to the amount of space occupied by conductors within a conduit. The NEC sets limits on the maximum allowable conduit fill to prevent overheating and ensure proper ventilation. When selecting conduit for a particular application, it's important to consider the size and number of conductors that will be installed. The conduit should be sized appropriately to accommodate the conductors without exceeding the maximum allowable fill. In addition to conduit fill, the NEC also addresses the issue of dirting, which refers to the reduction in the ampacity of conductors due to factors such as high ambient temperatures or the presence of multiple conductors in the same conduit. The NEC provides tables and formulas for calculating the directing factors that must be applied in various situations. When designing an electrical system, it's important to consider the directing factors to ensure that the conductors are properly sized to carry the intended load. Failure to account for directing can lead to overheating, voltage drop, and other problems. The NEC also addresses the issue of grounding and bonding, which are essential for ensuring electrical safety. Grounding refers to the connection of electrical equipment to the earth, while bonding refers to the connection of metal parts of the electrical system to each other. Grounding and bonding provide a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electric shock. The NEC sets specific requirements for grounding and bonding, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for bonding metal parts. It's important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. The NEC is a complex and comprehensive document, and it's important to consult with a qualified electrician or electrical inspector to ensure that your electrical system complies with all applicable requirements. They can provide valuable insights and guidance based on their expertise and knowledge of local regulations. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable working with electricity, it's best to leave it to the professionals. They have the training, experience, and equipment necessary to perform the work safely and effectively. Furthermore, the specific interpretation of the NEC can vary depending on the local jurisdiction. It's important to check with your local building department or electrical inspector to determine the specific requirements for your area. They may have additional rules or regulations that supplement the NEC. The NEC is updated every 3 years, so it's important to stay up to date on the latest changes. The latest edition of the NEC is available from the National Fire Protection Association, or NFPA. You can also find information about the NEC on the NFPA website. By staying informed about the NEC and consulting with qualified professionals, you can help ensure the safety and reliability of your electrical system. In conclusion, the determination of whether 2-inch RNMC in a residential garage, strapped to a concrete block wall 4 feet off the floor, is subject to physical damage requires careful consideration of the NEC, local codes, and the specific conditions of the garage environment. While the NEC doesn't explicitly mandate the same level of protection as in commercial or industrial settings, the principle of safeguarding against physical harm remains crucial. Factors like conduit location, material, securing method, and potential hazards must be assessed to determine the need for additional protective measures. Consulting with a qualified electrician or electrical inspector is essential to ensure compliance with all applicable codes and standards and to ensure the safety and reliability of the electrical installation.